Hello, folks. Dr. Lawrence W. Moore here again, and welcome back to Season 1, Episode 3 of Exploring Multimedia Art with P.D. Lork. In this episode, we're going to continue learning about uses for data structures in P.D. Lork, its own special brand of data structures, which Pure Data itself does have in a different way. And specifically in this episode, we are going to look at how you can use data structures for graphical user interface and actually use it as somewhat of a control mechanism. And the example we'll be doing is fairly simple, so you can kind of see how this works. And I'll be pointing out some things in the tutorials in PD Lork for you to do some further investigation. Okay, so let's get started. Okay, so here we are. I'm starting with a fresh folder with an image in it. The image looks like this. I did a search just for a gradient of white noise. You could probably download a similar image of your choice when you are making your own. Maybe even an ocean wave or something like that. After you hear what we're doing, you'll pretty much have some ideas. All right, but anyway, we are going to use that image. But let's open PD Lork here. Okay, now what I'm going to do is go to File, New. Make a new patch. If I can hit the right option. File, New. Looks like it's Control N. Probably Command N in Mac. And I'm going to stretch this baby out. Get as much of the screen as we can there, as we have left to us. All right. Now, I am going to start off by making a subpatch, an object, Control 1, Command 1 in Mac, PD. Let's call this background. Well, no. I am going to try something different and put all the structures together because they're simple. PD structures. Hopefully that isn't some magical word that takes up some sort of space in PD. I don't believe so. But in any case, what I'm going to do, actually I'll keep it about this big. Move it over here because we are going to be putting stuff over here. Now I am going to go into edit mode, and in this structures area I'm going to start off with what you need for data structures, the struct object. Struct, and I'm going to call this noise pointer, and I'm going to say float X, float Y. We know that we need to do that to start off any data structure. But I'm also going to add two more, float X1 and float Y1. Okay. Now, adding this X1 and Y1, what that does is that gives us an extra two pairs of coordinates that we're going to be utilizing to go a little bit more freely with things. because we are going to be making our own GUI controller for this interface. Next thing I'm going to do, make an object, and I'm going to call it draw image. Oh, I'm actually not going to make it till I save this thing. Good practices. Save as. Yep, this is the folder I want to save it in. And actually, this overall thing is going to be called, just so it doesn't confuse itself with the name of the data structure, I'm going to say noise space pointer. Now, a lot of times I don't like to make file names with spaces in them and things like that, because maybe some of the things I'm making will be loaded as abstractions into other pure data patches. But the limitation with the data structures is they don't graph on parent. So it's not likely this will ever be an abstraction in another patch. I could bring abstractions into this, but bringing this into other patches, since data structures don't graph on parents, is probably not going to happen. So I'll save it like that. Okay, so we have our, let's get our subpatch back up here. This is where we're keeping our data structures in. Now we can do that. Draw image. Since I gave this a location, I can then type an image name, gradient.png. And now I believe what I can do is give its dimensions afterwards. I made it 200 by 200 in Photoshop. And I want it to plot it such that it's upper left-hand corner, because when you're doing rectangular objects and stuff like that, the point of origin is always where it places its upper left-hand corner. I'm going to try to make that negative 100 by negative 100. And we'll see what I mean. Now the name of this data structure is noise pointer, all one word. Otherwise, if I would have saved the whole PD file as noise pointer, all one word, it would get confused because we have a data structure of that name. And plus we would have a file name in the folder, meaning this patch also, but you can't load a patch within itself as an abstraction. So that would be another error that would come up. So we've at least avoided that by naming the thing noise pointer, two words, so that this noise pointer comes up. And there we go. Okay. Now, I saw it down there. It probably located it down here when I made it up here, because it made its upper left-hand corner negative 100 by negative 100. Basically, this is a 200 by 200 thing. And what I would like to do is make the 0, 0 coordinates right in the middle. I have a feeling I may have done that backwards in a way. So let me check this out. A good way of finding out where we're at is let's draw a circle, because their radius is part of their creation arguments. We'll say, let's say 100 radius and 0, 0 its origin. Now oh boy, hold on. There we go. Let's see where it located that. Okay, I can at least see where the box is. So this thing's down here. Looks like I didn't want to do that. I don't see where the circle is that we made. Maybe I'm going about this all wrong. Before this, I actually didn't make these separate. I made these separate data structures, the background and so forth. And you know what I'm going to do? I'm going to do that again. Just delete that. I'm going to go here and just do what I know. Instead of calling it noise pointer, this is now just background. I'm still getting used to the data structures thing. Okay. Then I put in this object, and this time I'm just going to say draw image gradient.png without all the extra stuff. Okay. That means I should rename this to background. Not that that has anything to do with the data structures and organizing it. It could be named structures, but since it's only going to be the background structure, I might as well just name it background. So I just renamed that just for organizational sake. So here, let's make a new object and call it background. There we go. And I can use the grid work here to kind of line it up. Now, we're going to test something out here. We are going to pop a quick circle in just to see how our background is oriented, to see if there's anything we can do about it. Circle. Give it a radius of, yeah, this is overall a 200 by 200 picture. So let's give it a radius of 100 and start it at 0, 0 coordinates. We need the draw command. Okay, so yeah, the upper left-hand corner is thought of as 0, 0 of the image. Can we change that at all? I know the image's dimensions are 200 by 200. How would I make this 0 by 0? By going 100 in and 100 down, I think. Well, that got rid of our image. It didn't like that. It just didn't like that. All right, so it looks like it's best for me to continue doing this the way I was. Let's try. Does it bring it back when I do that 100, 100? Oh, okay, so the argument here is not putting in its height and width first, like you would with a rect command for draw, but you put where you want it to consider its point of origin to be. So I'm going to try the negative 100 by negative 100 now. Now we lost our circle. Why, I don't know. I don't know why that would just go away. All right, so we are just not going to put numbers in here. I'm going to go with the route I originally wanted to go. I just wanted to be able to pull this in and have its center be coordinates 0 by 0. But it just doesn't want to do that. So I'm going to get rid of the circle. And so, yeah, I'm not going to be able to layer this together. When you see what I'm going to do next, you'll see why I was thinking of trying this. It's just it doesn't want to do it. And I've had a day of it doesn't want to do it with PD Lark today, I tell you. All right, so we'll let that go be our background. Now, what we're going to do is make a subpatch for noise pointer. We're going to make something that basically allows you to play white noise in different filterings based on how you point on this map. So we're now going to make that pointer. We needed to make a new subpatch to make a second data structure. Struct noise pointer. Looks like it has it here in its memory from when I did it beforehand. So we'll pop that in. You see it has the float X, float Y, float X1, and float Y1 after it. Now, the previous one I made that's just the background has these in it too. I'm going to leave them there because earlier today when I had some data structures that didn't have it and some that did, the ones that didn't have this weren't using the extra 2 variables, but somehow it screwed up the one that was. I'm just leaving that in there. I think when you have a plan of using a data structure with the X1 and Y1 variables like we're going to use it, you need to make sure your other data structures that don't even use it still have it there. Otherwise, it screws things up. Okay? So, you'll see how we're going to use those in a bit. Next, we're going to draw circle. And this time it's not going to be 100. It's just going to be a 10 by 10 circle. So all you have to do, 10 by 10 would, if you put in 10 here, since that's a radius, it'll have a 20 pixel diameter. Actually, that'll be fine. I'm fine with that. But then after this, I'm going to put X1 and Y1 because that will help us control this circle. We hope. This can be tricky. Now, I am going to put in a load bang here because there's going to be some attributes I'm going to give it. And after that, I'm going to hit Control-Shift-B so that I have a bang that I can press while I'm putting things together. I could click this rather than having to load the thing again. But this load bang will make sure that when this gets opened, this message gets sent. So we're making a message box, Control-2, Command-2 in Mac. And first of all, what we're going to do is fill this circle, which we didn't make yet because we didn't put in an object named noise pointer. So, it's not there yet. This data structure is not there yet. But we're going to fill it red, 0, 0. That means full red and 0 are of the green and blue channels. So it'll stand out. And then we're going to put a stroke on it to give it kind of like a border. But I think it defaults to black, which is fine. So I'm going to type stroke width and make the width of the stroke 4 so it's not too overbearing. Now let's try that. We'll hook these up. Of course, I didn't really need the bang because in run mode, I could just hit this message and it'll do the same thing. But we got to make the thing first. So what I'm going to do is create over here, noise pointer. There's our circle. And I'm going to move it to where I think 0 by 0 is here. Because when you make circles, their center is the place of orientation. Now, these are two different data structures, but I want them to work together. Now, one thing I don't see there is the stroke. This doesn't need to be this wide. There we go. Now we can see it here. Even though the stroke is default black, it looks like or like fills are default black. It looks like it wants me to put it in. Otherwise, it's just not going to show the stroke around the edge. Let's try that. There we go. Now it let me put it in. You got to give it a color. You don't have to give it a fill color if you want it to be black because it will automatically do that. But I guess with stroke it's different. All right. Now here's another thing we're going to add to this. And then I'm going to show you something in the tutorials where you can do further research if you'd like to. I'm adding commas in between these different attribute commands. The next one's going to be drag 1. Now I can tap that in. Nothing's going to change here. But I'll show you what this does. Now, how come I have a circle up there? It might have made that. Oh, there must have been an object still sitting up there empty that was called noise pointer when I had the whole thing named noise pointer before. But anyway, I'm going to go to help and the help browser. If we go down to PDLork, data structures, and we go to tutorials, we were getting close to this last time, but I figured it deserves its own thing when you really kind of like round it out. We go to events. Now here's a patch where it shows you that now we're looking at the symbol box here. If I put my mouse over this, it says mouse over. I'm moving my mouse away, it says mouse out. But it's only doing this for this rectangle because we've given this rectangle a message that says mouse over 1, mouse out 1. So it will tell us in this output that it's mouse over when you put your mouse over it, and mouse out when it gets removed. Now this is because the draw object's been told that for this rectangle. And then this unpack S means unpack a symbol from this. Basically the output, one of the things that comes out of this output is a symbol that says either mouse over or mouse out when those actions happen. Now you can add other actions or events as they call them that are listed down here. Like drag is one of them. That's when the left mouse button is clicked and you're dragging. There's mouse down for, when you press the mouse button, and mouse up for when you release it. Those are up here. It doesn't say here whether this is just the left clicking or if you can isolate right clicking or a third mouse button or any of that. I don't know. I haven't experimented with that to find out, and it doesn't tell you. There's a lot of it doesn't tell you in these examples. So anyway, but that's what we're intending to use is drag instead. And that is something that is successfully used in another example here. But there's something special about this example that if you don't know this, then you're not going to benefit from it. I'm sorry, it hid the help browser. All right, so we're going back to the PD-LORC data structures, and we're going to go to demos. Over here, there's something called Curver, and then below it, we are going to go to drag event. So let's see here in Curver. All right. Now there's a lot of business here going on, but what we're focused on is the fact that there is a section where it creates circles that you could use as handles. Now here it's attached to these curves and attached to each other using a line here, which then becomes a dash array dotted line. These curves are made using the path form of drawing, which we are going to do a little bit with next week. It's one of the only ways I've found that you can make curves. I mean, you can make circles, you can make ellipses, but like if you want to do line sort of thing and actually have some curvature to it, you got to use the path command to do it. But I digress. Anyway, what this tutorial is trying to show you, among other things, is here, drag event. Now, if we just click on that in run mode, left click, we get to see the insides of drag event. It is an abstraction. It's an abstraction in this folder. And so you might say, okay, I'll copy and paste this out into my patch and use it there. Well, you can't copy and paste it out as a sub patch because it won't work right. This has to be copied as an abstraction. And in fact, you can find it in its full entirety. Or what we're going to do to get it is actually just go back here and go to drag event, not drag event Y. We're going to do drag event. We're going to get this patching out, and then I'm going to improve upon it for our purposes here. Going to go to File, Save As. Here's where my folder is. Contains noise pointer, yep. And we're going to name this. Now this, we do want to make it all one word using either hyphens or dashes to connect it. I prefer underscores. So I'm going to call this point underscore master. Okay. Just for the heck of it. So now I could close it there. That was from the help browser. And then I'll explain how this thing works and alter it for our purposes here. I'm going to make it right here. Control 1 to make an object. Since I saved it to the file name point underscore master, I can load it right in. Now this is meant to be loaded in with a number of command line parameters after it. And there's actually 3 of them. First should be the name of the data structure you're interacting with. It's called noise pointer, all one word, all lowercase. And then the coordinates that you want to interact with. Those are the ones, the new ones called X1, Y1. Those are also the coordinates here saying this is the center point of this circle. And so what we're trying to do now is take the drag event that comes out of here and actually control this circle's center point. In other words, move it around when we're dragging the mouse. So we're going to right click on it and go to open. And let's edit here. And I'm sorry if you're hearing Cigar Box guitar in the background. My wife is just working on one of her videos and playing her guitar, more so than working on the video right now. And I can hear it bleeding through the walls, so you could probably hear it too. Sorry about that. All right. So anyway, inlet. That's the inlet where drag event's supposed to come in. Let me move this over so we can see what's happening. This is what we have open. This is the abstraction that we have open. If we would have put this in as a sub patch, like PD space, a name, and then all this patching inside, it won't work right. It needs to be an abstraction. Now, the thing about abstractions is when you put in creation arguments like noise pointer, X1 and Y1, 3 different creation arguments in order. Any objects in here that have $1, $2, $3 are drawing upon those creation arguments. Any message boxes, obviously $1, 2, or 3 means what it's received through its inlet in order. So that's different. But any objects, the reason why the $1, $2, and $3 doesn't work the same way as it does in messages in objects is because it doesn't work the same way. In objects, it's looking for command line arguments for whatever patch this is in, if it has any. If it doesn't have any, you're not going to get anything. Like if it's a parent patch like this one, it wouldn't get anything. But since this is an abstraction that was created using creation arguments, then we are getting those creation arguments. So here's the inlet. That's where drag comes in. And actually drag comes in with a bunch of things following it. Not a bunch of things. 2 main things. And it goes first through a route object. And route drag. That means when things come in and the first item in their list of things being stated, and this is what's going through the inlet here, the route will route it out certain outlets depending on what's there. We could have drag, horse, cow, whatever, a series of things. If anything had horse as the first word in it, it would come out the second outlet or the third for cow. And there would always be an extra one for none of the above. Drag's the only thing that's going to come out of here because we've only set this to output drag lists. So when drag comes out, route will put that information out its first outlet and take the word drag away. That's how route works. It's basically like whatever's at the beginning of your list is how you're going to route things, and it gets taken away by the route object. And that what follows then gets used. And here there's really 2 things that follow. And that's set to a trigger, anything, anything. This could also be abbreviated TAA. What that means is the trigger will just take whatever comes in and send it back out again. Because, it's not limited to being a float. It's not limited to being a symbol. It's not limited to being a bang or any of the other things that we use trigger for. Anything literally means anything. So it sends anything out here, and it sends anything out here. Now, out here, it goes into a message $2, $3. What that means is in this clump of anything that's coming out, the second and the third items from this message are being taken out. This has nothing to do with the creation arguments here. That's only objects. that derive their $ variables from that. And so $2, $3 actually are going to end up being coordinates. Basically, the coordinates of where the mouse is now that it received a drag event. We received a drag event. What are the coordinates? That's what happens. And so this unpacks those coordinates because they come in a single message. And then we get our X and our Y coordinates here. Now this anything also goes to an unpack. And here it unpacks it as P. And P goes straight into the get object here, which is something that is part of the normal pure data structures commands, and pdlorc seems to utilize them as well. But what the get command does is it needs, first of all, what data structure are you talking about? Our data structure is noise pointer here. Okay, and since that's the first creation argument, get $1 is going to be noise pointer. Get $2 and $3 are going to be X1 and Y1. So get 1 is going to be getting the coordinates X1 and Y1, having been fed a pointer variable. Not variable, but a pointer message. And a pointer message is really just the two coordinates, X and Y coordinates, or any data set, basically all, or a data set of coordinates, and that's what it ends up being for pointer, put together. But that's all get is receiving that information, but it's getting from the data structure what X1 and Y1 are, and it's feeding them over here. So we have the X coordinates of both of these methods of getting the coordinates down being fed to adders, so that two X's are being added together here, the two Y's are being added together here. What it ends up being is, if I were to click and drag this mouse, there's a point where I click and I start moving, and I continue moving. Who knows how much I continue moving, and the coordinates keep changing as I move. What this does, this system, is basically it'll catch this first, which is the rightmost thing, because PD functions right to left, and then it gets this again, the leftmost thing, and they're going to be similar things. So it's almost like you get the newest motion and you're adding it to the oldest motion, so that way you can try and keep them together. Otherwise, the coordinates tend to flip and change a lot. I've done some experimentation this afternoon, and that's what I've seen happen. So that's what I'm sticking with. So now that we've added this, we are going to change it. But before we do, we can use this. This orange here just means that I didn't save it. You hit Control S, you see the orange goes away. All right, let me go back here. And we're going to go into run mode, and we're going to grab this circle and drag. See, we can move it now, but we can move it all over the place. I want to just move it within this square. So that's what we're going to do. We're going to alter this to limit its movements. So I'm going to open this subpatch again and move that back up. So I'm going to move it back down because we need space. So here we're getting our X coordinates. Here we're getting our Y coordinates. And then this command at the bottom, set. It says set $1. $1 is noise pointer. And then here's your X1, here's your Y1 coordinates. Okay, so it's basically saying as this mouse drags around, that's where you're going to go. Trailing the mouse pointer is really how it's doing it. I know it's still a little bit like weird, but I've done the hours today, and this is how you got to do it. So anyway, we're going to limit its movement, though, to the square image we have. So we're going to do that with Moses, and we're going to add some more creation arguments. Moses $4. And we're going to have Moses $5. Let's just make 2 more of these. Actually, instead of duplicating them, I'm just going to have them always be Moses $6 and Moses $7. There we go. So now, okay, so yeah, now, let me see here. We're going to go save this, Control S, and we're going to go back over here, and this is what we're doing, because Moses is an object. If we add a 4th, 5th, 6th, and 7th creation arguments, it'll use those. Negative 100 by 100 is going to be the limits of our x coordinates. Because in a 200 by 200 picture, when I planted this thing pretty much kind of in the center, relatively, it's negative 100 and it's positive 100 are going to be the 2 horizontal sides of the picture. So we're keeping ourselves within frame of the picture. And then the y coordinates will be negative 100, 100. So basically what I'm doing is I'm saying, as we go 100 pixels this way, that's going to be your limit. 100 pixels this way, that's your limit, and so forth. And I'll show you how Moses works for doing that in just a moment here. Let's save this so far. Get you out of the way. No. I guess not. I just need to open you again. I guess because we just put in those creation arguments. So now what Moses does is numbers that are coming into its left inlet, in this case the x coordinates, if it's less than the value here as its creation argument, or fed through the right inlet, but we're not feeding anything through the right inlet, so it'll check $4, which we're setting as our minimum for our x coordinates. If it's less than that, it comes out here. If it's that or higher, it comes out here. But it'll send out the numbers of these x coordinates that are coming. But we don't necessarily want those. Since this is going to be our minimum, here, from experience, it's nice to put it over there. We're going to have this trigger. If it's less than this number, less than our minimum, that means no, you don't want that. We're going to trigger a bang, and the bang that we're going to trigger is going to be a float box with $4. Oh. Float space $4. And so what that means is float means just a number box. Not the number box where you view the number, but a storage box for floating point values, which are numbers. And since we put in a creation argument, it's going to say, okay, my initial value being stored here is $4. And all it's getting in its left inlet is a bang. And that bang says, all right, bang out this number. This number won't be replaced because we're not going to have anything replace it. So it means whatever that lower limit is, if it's less than that, send out the number that's lower limit. In other words, it'll keep you right at that limit line. Now, if it's higher than that lower limit, it can come out as well. and go into the next Moses, because this one is going to control maximum. Okay, so we're going to do the opposite of what we did before. If it's less than what comes out here, it's all good, and it's going to be our X coordinate. I'll have to stretch this down to make things look good later. Now, if it comes out the right outlet, that means it's $5 or higher, which means our maximum number. In this case, 100. So we want to, in that case, trigger a bang. Like the number is what's coming out, but since we put a trigger there, it converts it into a bang. Since we didn't put an F, it's not going to give us the float that's coming in. But that's what we want. We don't want that. We want it to become a bang to tell this float box to send $5. Excuse me. And that's what will be sent. It's like if you're the max or higher, the max is all that shall be sent. So it keeps you there, basically. Keeps you in between negative 100 and 100. And we're going to do the same thing with the Y coordinates. Now I not only have cigar box guitar, I have a cat. Cat Inga is complaining. Alrighty, so here's our Moses for that side, and it's going to be the same thing. I'm going to make a trigger bang, and then a float, except this time it's $6, because it's creation argument 6 that is the minimum for our Y coordinates. That shall go into the next Moses for determining whether things are within the maximum. And of course the right outlet goes straight into it, just like this side, but we're using different creation arguments here. So now here on this side, if it's lower than the maximum value, it goes out. If it's the maximum value or higher, that's when we trigger a bang. And then a float. $7 is the maximum Y coordinate value. All right, and then this gets connected up here as well. Now, before we leave here, I need to add 2 more things that will make the cabling look a little messy. So right now, if you're following along, now's a good chance to get a good, hold on, I'm going to find a good pause point for you. Now's a good pause point to capture this. Okay, so now I'm going to put an outlet here and another outlet, because we want to take these coordinates out and do stuff with them. So the thing is, we're getting them from both. Like the X coordinates, we're getting them from here as well as here, because they're going through the second Moses, and that's where they end up. We want both. And then here and here. The reason why we want both, oh, no, from the bottom, though. Hold on here. Let me make sure this is from the bottom. Yep, from the bottom. The reason why we want both is because when you get to the edge, and you get to the max value, we still want it. Because what Moses does is, like this being 100, if you get to Y 100, 99 would come out through here, but 100 wouldn't. 100 would come out here because it's this or above. So we need 100 to be trigger 100. It's just if it gets to 101, it won't let it. It'll just trigger 100. And so basically that's the way it's going to go. It's going to limit things. But we want outlets. I'm going to hit save because remember this is an abstraction on disk, and this usually highlights orange when it has been changed and hasn't been saved. Okay, now that we did that, we have two outlets on here that we can use those two values. But let's check this out now. We're in run mode here, and I cannot go beyond those values that I set. So let's just leave it somewhere back in the middle. Oh, that's something we can add. If we want to center this thing, we want to be able to send it a message, receive, center pointer. But this, we're just going to make a bang. So on this center pointer that receives a bang, it'll bang out a 0. And those zeros are going to go here, here. Now, when I did this before, I actually did it differently, but I'm going to try this to see if it works better. If I have problems, I will have to fix them. And we want things to start off centered, so we're going to put a load bang here. Also, ready to tap this message box. So that way we could use a bang from outside to center the red circle. I'm going to hit Control S to save there. And on load bang, it should be centered. Now let's save this. Let's save this. I am going to load and test that. Now let me make sure PDLork is fully closed. Close its console window. And we're going to open noise pointer 2 words. Okay, can we move this? Yes. And it keeps it to its maximums. Now, that message is called center pointer. I'm just going to make a bang right here. Properties. Send symbol center pointer. How about we give it the same background as the pointer itself that it's centering? It would make sense. Okay, let's try it. Boom. Well, it didn't. It didn't quite do it right. So it looks like, hold on here. We're going to have to do this differently. You put this 0 in all those things. and something didn't go right. It didn't like it because it centered it towards the bottom, not actually in the center. Let's put it into the Mosai. Save, and then close that window. Save, close that window. There we go. That's center. That's center. There we go. Now we can label this center and make it a little bit bigger. Its size is 15. Well, what's the size of the it made its radius 10, so that makes it full 20 diameter. And text for the label, center. Now, this X and Y coordinate, let's see where that puts the label. It probably is not going to look right. Yeah, it's putting it right there. So let's put them. Zero X coordinate, and the Y needs to be negative. Let's put this at negative 17. How about that? Too high. Just make it negative 7. Okay. There we go. And when it's centered, it's up here. So let's see if we can get that bang up there too. There. All right, good. Now we're going to do the audio portion of this. The sound. What I was intending to make is a noise generator that allows you to get different aspects of noise when you swish it around. Basically filtering. We're going to go back to this first. And here with our outlets, this first outlet is going to give us X coordinates. I'm going to use that to send frequency values for the center frequency of filtered noise. And you'll see what that is in just a moment. And here, I'm going to use these Y coordinates to send out, well, it's called bandwidth, so I'll say width. I was going to call it Q, but that might be dangerous using a single letter symbol name for something, because it's also called Q. Bandwidth and Q are basically for the same thing in this circumstance. Okay, so now let's make our sub patch here for PD Noise Maker. All right. Now let's see. Let's make sure we are all on screen. We are. Now this is what makes noise in PD. An object called noise tilde. It just generates white noise. And what we are going to hear in just a moment will be white noise, DAC tilde. Make sure your volume is not too high. This might blast a bit. Once I turn audio on, I'm going to use the shortcut. All right, that's white noise for you. You know, but now we're going to filter it. Which means we're going to make a VCF tilde, voltage controlled filter. Now, it's not actually using voltage because this is digital. This is not analog, obviously, when you're doing stuff in software. But it is basically imitating a voltage controlled filter where basically we have our signal coming in here. And then we can use an audio signal, although in this case, it's not going to really be audio. But we're going to use our X coordinates here to control frequency, like lower frequencies towards this side, higher frequencies towards the right side. And the way we'll do that is we're going to receive from those. I hit Control R and it put it down there. No, Control 1 and it put it down there. All right, let's type in here, receive, please. R, what are you doing? It did do it. Okay. Wonder why it's delayed. It's weird. Okay, receive, FREQ, freak, is what we're sending out. And we'll see those values come in here. I like to put number boxes at different steps of the way when I'm patching, just to kind of make sure everything's coming in properly. And the math is correct. And the range is going to be negative 100 to the left and positive 100 to the right. It's going to be somewhere between that. So we're going to change those by adding 100 to it. That changes the range to 0 up to 200. Negative 100 before was the bottom of the range. Add 100 to it. Now it's 0. 100 was the upper maximum range. Add 100 to it. Now it's 200. Okay. 200. We're going to multiply that by 100, which will make it now a range of 0 to 20,000. Kind of like the human range of hearing in ideal circumstances. But 0, we don't hear anything 0 to 20, definitely. So what we're going to do on the bottom of that is, instead of times 100, we're going to make it times 99, which means it goes up to 19,980. All right. And then we add to it 20. And now its range is 20 up to 20,000, the ideal human range of hearing. And then we add a number box below it to make sure that's what we're getting. Here, I just want to move this stuff down. Come on. And that goes into the left inlet. Now we're going to test this out after we have the other bit in, because the filtered noise, unless you have Q settings or bandwidth settings for the filter, it's not going to mean a lot. Now this is typically, you can send audio rate signals in here to change your center frequency. I don't know that there's any advantage to doing so, although one way of doing so that's smoothest is go pack F50 and then put a line object underneath it. What pack does is it packs two items together. A float here, in this case, because we signified F and 50. So F, since this is the left inlet, is going to be whatever number comes in here. 50 means 50 milliseconds. They're sent out as one message to the object line tilde, which will make it an audio signal, and at the same time smooth out any jumps in the numbers over 50 milliseconds. So there we go. Nope, we're not trying it till we do the other, because we need to give it, otherwise it'll still just sound like full spectrum noise without having a width here. So now we're going to receive width. This is our y-axis stuff. We'll see the numbers here. Now this is on a range of, once again, negative 100 up to 100. So we're going to add 100 to it to make it 0 to 200. And then we're going to multiply it by, 0.1. So it's a range of 0 to 20. Although we really don't want 0 to come in. But we could probably handle that. Because the Q number here, a bandwidth number in PD for the VCF object is kind of weird. I just found it to be kind of like close to 0 up to 20 is a good useful range. You know. So anyway, we're multiplying times 0.1. Let's make it 0.99. And then we'll add a plus 0.01. So that way it doesn't go to 0. But it should go up to 20. Because we're putting a 0.99 there on a 200. So it should go up to close to 20. Well, we'll see. Now this does not take audio rate inlets or audio rate signals, so that goes straight in. All right. I'm just try and keep this open. In fact, I'll collapse this one a bit so we can see this patch and see those values coming in there. Now I'm going to turn on audio and run mode on this side. So we get the higher frequencies as we go right. Right about here, they're starting to disappear already. Closer to the top means less distinction. Closer to the bottom means more distinction of the frequency that you're selecting. So some might want to curve this a bit, or maybe only have it go up this high and extend that range to here using some math. But I'm fine with it. The thing that I want to do is make these the opposite. All right, turning off audio. I want to make it more defined when it gets up here and less defined when it's down here. Because here on the image, there's little dots, and so it's more like precision. This is more like snow, you know, and noise. And the way we can do that is inversion over here. And we could do it halfway down the line. Like this right here is converting it into 0 to 200. Here we could just go swap 200. And the next object we're going to make is a subtractor. Hook up both the left and the right outlets here. and then it comes out here. So basically what you're getting is 200 minus whatever's coming in through here, which will always give you the inverse. So now, let's test that. Turn on audio. Yeah, we're getting the defined, more pitched tones up here. And the snowier ones down here. Alright, so there we go. Now, you can also make like some volume control and stuff for it. Let me just close that subpatch. That subpatch being over here. But the last thing I'm going to add to it for here, for this demonstration, is going to be the load bang to turn on audio. And then I'm going to have the message to turn audio off right next to it. So here, Control 2 gives us a PD DSP 1. So when this opens up, it'll be on. But you'll have right here, next to this message, the ability to turn it off. Or use your shortcuts if you're down with those. But I always like to put these in for people that, you know, don't know to hit their shortcuts right away. So there we go. We got a new instrument made. I'm going to save this as it is and take a screenshot of it. That I will use for the cover. Yeah, there we go. For the thumbnail. All right, well, thank you for joining me. Hopefully you've learned a bit from this. I know this is just all simple stuff, but if you go into the demos and tutorials, it gets a little more complex. And this was basically some simple way of showing you this stuff, whereas the other stuff you'll be staring at for a bit in the demos before you figure it out. All right, folks, thank you very much. Stay free and take care until next time.